Just a run through of some of the main calculator steps on 33, just in case you need a little help getting started. So we go to stat first, then edit, and we get these years and the populations in here. And again, these are in millions, sort of like some of the other problems that involve population. And we're going to be asked to find 4 different models: linear, power, exponential, and logarithm. So first up, I'll show you how to do linear and show you some things to try along the way to make it a little bit easier on yourself. So first up, actually before I do any of this stuff, there's a correlation coefficient that I told you could skip on the homework, but let me tell you about it because it's actually the way you want to get the answer to these. It really helps do that part. So to get that, go to mode. There's a couple ways. This is the easiest one I know of. You go to mode and you come down here to the stat diagnostics. Make sure that is turned on, and that'll give you that correlation coefficient when you calculate the regression equation. There's a lot of big words. I'll tell you a little bit more about what they mean when we get there. So make sure that's on, and that's going to make things a lot easier. So stat edit, we get these in here. Then I go stat calc. First up is a linear regression. So option 4. And list 1, list 2 seems good here. Now, I always like to store my regression equation. That way I don't have to type all this stuff into y equals. It's done for me, and it keeps all the decimal places the calculator comes up with, so I'm not rounding it. It makes it more accurate than what I would have typed in anyway. So to do that, we go to variables, or the vars button. Go over to yvars, because vars is just more fun to say. I want a function. And really, that should make sense because you don't, at this point, probably know about any of these other things. So function's the only thing that makes sense to you. And you can choose whichever y1, y2, and so on. This is just where it's going to go in your y equals menu. So we'll go with y1. That's our first one we're going to try. And then we're going to hit calculate. So as it's coming up with the equation, it's also going to put that in y equals for me and make this a lot easier. So by turning on the stat diagnostics, I also get this stuff, which I'll talk about in a minute. But we're just plugging in your slope for A, your intercept for B, and that's your linear model for the data. R squared is your coefficient of determination, and R is your correlation coefficient. I believe I got both of those right. Just to put it simply, they're a measure of how strong one list of data impacts the other list. So in other words, as the years go on, is the population tied to that in a predictable way? How reliable is our data? I guess that's a good way to put it. What you want to do as you're checking these different graphs or these different equations, look at the R squared number. The closer it is to 1, the stronger the relation between the two lists of data, which tells me that how strong of a prediction this is. So this is a pretty strong prediction, 0.9987. On the flip side of that, if it's close to 0, it's very poor. And then you can go from 0 to -1 if there's a negative correlation. So if over time the population was dropping, that would be a negative correlation. So this is a pretty good coefficient right there. It's pretty close to 1. When you choose later which one of these models is the best, that's what you want to be looking for. But again, when I go to y equals, it's going to be put in there already for me. Clear that out to avoid some confusion. And again, it's got a lot of extra decimals that I probably would not have typed in there myself, so it's going to make it a little more accurate. And now we just go through and do the other options. So I'll show you real quick where they are, and then I'll kind of skip ahead. So logarithm, we do need to pick natural log. For a power regression, that's going to be option A, and exponential is going to be option 0. So I'll go ahead and get all these in here. Same process as before. When I come back, I'll talk about the graph. Okay, so now I've got all 4 of my equations in here. I want to tell you how to make sure you get the data to show up. So go to second and y equals or stat plot. Right now this is off, so I need to get that turned on. So just hit enter to go into it, hit enter for on when it's highlighted to toggle it on. There we go. I do want a scatter plot chosen, so that's good. List 1, list 2. You can pick whichever color or dot choice you want. I'm going to stick with those. Now, the easiest way to get this to show up is to do zoom 9. And before I do that, because as soon as I hit 9 right now, it's going to actually zoom in on the part I want with the data. It's also going to go ahead and start drawing everything in the background. So real quick, just to kind of see what's coming up. Blue is going to be the linear model. Red is going to be the power regression, which we haven't done much with in here. Black is going to be exponential, and the pinkish purple is going to be a logarithm. So I'm going to go back to zoom, hit 9, zoom stat. So there comes the linear model. It's looking pretty good. Next is going to be the power model, which is also pretty close. Then it'll be the exponential. That's also hitting pretty close. They're all hitting about the same place. Last is a logarithm, which is also pretty close. All right, so this one's pretty tough now we've got all 4 graphs because they look really similar. All these are going to be pretty good models, at least for this piece of the data, for the short-term, near future. Now, long-term, many years from now, they may kind of veer off what's really going to happen. And also, for populations, a logistic model is almost always the best bet. And I'm kind of surprised that book didn't ask you to do logistic on this one. What you really want to use is that R-squared value, that coefficient of determination. I think I gave it the right name. The one that being closest to 1 is your best bet, and linear was the one that just barely won out over exponential, which was maybe 0.05 of a decimal place away. So linear would actually be your best fit here, and that's how you're going to tell. That's the best way. And if you have questions on the other pieces of this, let me know, and I can try to address those. But that's the main thing I wanted to go over for this problem.